Gents, welcome back. Hot on the heels of arithmetic progressions last week, what I'm going to do is have a look in a similar way at what's called geometric progressions. So we're going to look at what they are, going to find out how to calculate the nth term of a GP, calculate the sum of n terms, and look at solving problems involving geometric progressions. That's the plan anyway. Okay, when a sequence has a constant ratio between successive terms, it's called a geometric progression, often abbreviated to GP. Constant is called the common ratio, R. So, take examples 1, 2, 4, 8, where each successive term has got a common ratio of 2. So it's the previous term multiplied by 2. More algebraically, we can say A times R squared, A times R cubed, and so on. Yeah. So every step is an increase in the index. All right. So, how then? A general term for for finding the nth term of a geometric progression. So if the first term of a GP is A and the common ratio is R, then we can find the nth term from the formula A times R to the power of n minus 1. We can readily prove that from the earlier example. For example, the 8th term of a GP 1, 2, 4, 8 is given by 1 times 2 to the power 7, which is 128. Okay. Now, unlike arithmetic progressions, it's not always easy to see what the common ratio is. So you can usually pick out fairly easily in an arithmetic progression how much we're adding or taking away on each term. That's not always so easy in a GP. So if you can't, you can find R from the formula R is equal to A times R over A. Yeah. So that will give you that. So let's have a quick look at a couple of examples. Determine the 10th term of the series 3, 6, 12, 14. What's the common ratio here? 12, 24. Sorry. Yeah. And I is first term of 3. Yeah. We want to know the 10th term, which is given by A times R to the n minus 1. So it's 3 times 2 to the power of 9. Which is nope. 1,536. Put the what? You add 3 to the power of 9. Yeah. Alright. Okay. So it's fairly reasonably easy given the formula. One thing I was going to say to you this week, if I was you, a good tip I always had was, if you've got a book like Macaulay's got there, reserve some space near the beginning and put all the formulas that you use and come across in one place. So if you want to find formula, you can have a look in the front or in the back of your book even. Yeah. So where you're given a formula, write it down with all your other formulas in a place where you know it's easy to find. All right. So that's finding the nth term. I ain't done some term. No, I haven't done. So look, find the sum of the first 7 terms in the series. I got ahead of myself. Right. Unless that's my handouts that are out of order. Go, jump ahead. Right. Yes. You can find, so generally to find the sum of n terms of a GP, there's 2 versions of the formula. All depends on whether r is greater than or equal to 1. Because if r is less than 1, so greater than or less than 1. If r is less than 1, the progression is going to diverge towards 0. Every term is going to be smaller than the previous one. And if r is greater than 1, it's going to diverge and get bigger as we progress to all the terms. So there's 2 versions. One version when the common ratio is less than 1. It's there. So the sum of n terms is a times 1 minus r to the n over 1 minus r. And then where the common ratio is greater than 1, we use a times r to the n minus 1 over r minus 1. So they're slightly different. You need to make sure if you're doing a problem, you get the right one. So the first thing is to find r, and then to use the correct formula. So in the example, sum of first 8 terms in this GP, we're multiplying by 2, so r is greater than 1. We're using this version of the formula. So it's 1, which is the first term, times 2 to the power of 8 minus 1 over 2 minus 1. Get the sum of the first 8 terms is 255. Okay. So depending on whether the common ratio is greater than or less than 1, you have to select the right formula for sum of terms. All happy with that? Yeah. Right. Now we can go back to the problem I tried to put in front of you in the first place. Which was on page 3, I think. Something like that. Back up here. Find the sum of the first 7 terms of the series 1/2, 1.5, 4.5, 13.5. So A is 1/2. What's R here, the common rate? What have I multiplied the first term by to get the second term? 1/2 to 1.5. How many halves in 1.5? 3. Yeah. So we've got an r greater than 1. So the sum of the first 7 terms is equal to a r to the n minus 1 over r minus 1, which which is a half times 3 to the 7th minus 1 all over 3 minus 1. Plug those numbers in your calculator. What do you get? Point 0.25. That ain't the answer I've got here. I got 546. It's not 0.25. Five, 4, 6.5, yeah. Or 0.5 if you prefer. When you put the brackets in, yeah. If you don't put what's happened there, if you don't put the brackets in, what you're doing is you're doing a half times 3 to the 7. Well, the first thing you're doing is 3 to the 7, because indices come before multiplication. Then you're doing half times that, and then you're taking 1 off. Brackets mean you're doing what's in there first and then multiplying it by a half. Right, so effectively the minus 1 is getting multiplied by a half as well. Alright? Yeah? Right. First term of a geometric progression is 12, and the fifth term is 55. Determine the 8th and the 11th terms. So, I is equal to 12, and the fifth term is 55. Determine the 8th term and the 11th term. How are we going to do that? We know that we've been given the fifth term, okay? So the first term is A on its own, second term is AR, third term is AR squared, fourth term is AR cubed, fifth term is AR to the 4. Yep. So, from that, we know that AR to the 4 is equal to 55. That's the hook into this question. Yep. Draw that down here. I times R to the power 4 equals 55. What do we need to find from that? What are we looking to find so that we can find out what the 8th and 11th term is? What's the missing piece of the jigsaw? The common ratio R. So we need to rearrange that formula there so that we got R on its own. So what we're going to do first. Divide by. So we're going to go like this. Which effectively means that we could do that and make that a 3. Has that helped us? Yeah? Okay. So we'll rub that out. You've got to divide by something, Logan. but R isn't the one. Yep. Just put that back. So what do you think? Divide by A, yeah. So that's what we're going to do. What happens when we divide by A? We end up with R to the 4 is equal to 55 over A. How do we get rid of the power of 4? How do we cancel the power of 4? Not cube root, the 4th root. Yeah? Because we cancel a square by a square root, we cancel a cube by a cube root, so we must cancel a the power of 4 by the 4th root. So we're going to do root to the 4 both sides. Yep. Taken root to the 4 of that side and root to the 4 of that side. Cancels that 4. Yeah, and just leaves R on its own. So we now got a formula for R of the 4th root of 55 over A, which is 12. Plug that in your calculators and give me the answer to 7 decimal places at this stage. Yeah. What we got? Okay, for the 8th term, 4 significant figures. Oh, what's the answer? 0.3 recurrent. What's a better way to write that then? 1/3. And we don't round it. Yeah. All right. So we now know that the common ratio is 1/3. All right. We're taking this term that is 1/9. Okay. And we know that's equal to A R to the n minus 1. We want to find n, don't we? Which term is the term equal to 1/9? So how do I rearrange that for n? AR3. No, R is 1/3. That is 1/3. How do I rearrange that so I've got N on its own? How do I get A over this side? Divide by A. No. Come on, boys. How do we do this now? How do I get N, R? How do I get N on its own? I'm not doing all the work, come on. How do I get R on its own? N on its own, sorry. What is R? What's it equal to? 1/3. Calculate to the power of N minus 1. And it's equal to 1 divided by 9 times A, which is 2187. Anyone see how you can do this? Can you see what we can write these as in numbers to the power of something? Preferably 3. What power do we have to put on 3 to make 9? So we can write that as 3 to the 2. Yeah. What power do we have to write 3 to make it 2187? How can you find out? That'll what? 3 to the power 46 is 2187. type the answer. If you square root 2187, what do you get? What about if you do the 7th root of 2187, what do you get? Yes. I got the answer in my hand. I want you to tell me how you do it. Oh. Well, that's one way to do it, isn't it? How would you do it? What's wrong with that then? How can I write that as 3 to 1 power? Now what? How can I take that power outside? I can write that as 1/3 to power 9. We're going back to the laws of indices here, remember? Yeah. So that is 1 to the 9, which is still 1. 3 to the 9. So overall, what we're saying is 1/3 minus 1 equal to 1/3 to the power 9. So what's n minus 1 equal to? Third times n to the minus 1 is equal to 1/3 to the power 9. So what's n minus 1 equal to? Therefore, 10th is equal to 1/9. I can tell that. I can tell that you're all completely lost. Don't worry about that. Okay? Mental note not to put a question like that in your assignment pen. Right. Problem 15. Find the sum of the first 9 terms of the series 72, 57.6, 46.08. Alright? So, A is 72. How do we find R? We take the second term, A times R is equal to 57.6. Been given the first, second and third terms. If we do that, we can do AR 57.6 divided by 72 equals. Where? That's A times that. 0.8. Remember these terms, this series, geometric series goes A times the common ratio, Macaulay. The first term is A, second term is A times the common ratio, third term is A times the common ratio squared. Yeah. If you've got any two terms, you can find the common ratio. Alright? Because we could equally, if we do IR squared, which is that term, over IR, we should still get, that would be 46.08 divided by 57.6. Just check that we still get 0.8. And is 0.8 what we would be expecting? Less than 1 because the terms are diverging. Convergent, sorry. And we want to find the sum of 9 terms. We're looking for the formula where R is less than 1. So that's A 1 minus Rn over 1 minus R. It's 72. What do we get with that? Be careful, make sure you put the brackets in, and I would suggest you use the fraction button. Four significant figures, please. $311.7. Alright? Now, what we're going to do now is have a look at a problem that has a more practical nature. Typical geometric progression is compound, what they call compound interest. You put money in the bank and that geometrically gets bigger because you get interest on the interest. Listening, boys? Good. So, £100 is invested at compound interest rate of 8% per annum. So we start at I and interest rate of 8% per annum. So what is R, the common ratio? Are we looking, first of all, are we looking for a geometric progression that diverges or converges? We put money in the bank with interest,
we want it to get bigger. So we know it must be greater than 1. Yep. If that was 2, the interest would be 100%, wouldn't it? Because we'd be doubling every time. So what's the common ratio here? Knowing that it must be greater than 1. We want 8%. 1.08, yeah. 8 parts of 100. Yeah. So 1.08. Determine the value after 10 years. Aye. What's that looking for? Yeah, exactly. It is the sum of 10 of the terms. Yeah. So which formula do we want? No, we want, hang on, do we want to find the sum of 10 terms? Is the bank going to give you the £100 every year as well? Yeah. So what we want to know is how much is in that bank account year 10. So we want to know the 10th term. The sum of 10 terms is going to go 100 plus 108 plus 108 and a bit more, isn't it? That'd be the sum of all the terms. We're not going to give you the £100 every year as well. We're only going to give you the 8% on what the balance is. So we're looking for here the 10th term. So the 10th term is given by how do we find the 10th term? What's the formula? I R to the n minus 1. Yeah. I is £100. R is 1.08, and I raise that to the power of 9. Pounds and pence, please. Nope. Hang on, why is it? Hang on a minute. Yeah, because I'm looking at what my friend. This problem comes out of that book, and he's done. I'm just reading it because the first term after 10 years, what you got to remember is that's £100 after 0 years. So you've got to look for the 11th term here. Can you see why? Yeah, because then after 10 years that'll be the 11th term. So that should be Just put a note there, first term is the investment. So we want it after 10 years, we're going to be looking for the 11th term. You all understand that? Yeah? So that needs to be to the power 10. And then you should get £215. I make it, he's got 89. Have you rounded it correctly? No, because that's not more than 5 or more. So you don't round up. That's right. Okay. So that is how much would be in that account after the 10th year. Yeah. Alright. So B is when will reach more than £300. Okay. How can we tackle that problem, do you think? Well, we can write, we know that this is a particular term. Let's leave the pound sign out. 300 equal to R to the n. We want to find n. Yeah, somewhere. Alright. So 300 is equal to 100, which is A, times 1.08 to the power of n. Alright, now I'm going to teach you briefly something that we're going to go through in full detail next week. But to solve that problem, you need to use logarithms. Yeah? Alright, so first thing you do is you take log of both sides. Yeah? So we say log of 300 hang on, can you see where we can simplify that a bit first? Can we get rid of that 100? If we divide by 100 both sides, what are we left with? 300 divided by 100 is 3. 100 divided by 100 is... Who said nothing? Yeah, all happy with that? Yeah? Now take log of both sides. So we can say log of 3 log of 1.08 to the n. Alright, now One of the laws of logarithms is, third law in fact, put it here, log of I to the n can be written as n times the log of A. So that's the third law. Can you see how I can rewrite this side, which will enable me to get n on its own? If I apply third law to that right hand side, so let's put it up here. Apply the third law of logs to the right hand side, so we can write log is equal to. What does that third law there mean I can do with that? How can I rewrite that in terms of third law? What's A in what's next to A? What's A? Yeah, so we can n is, so we can you see that we can write that as n times the log of 1.08, and there's a times in there. So now how can we get n on its own? We're dividing by log 1.08. Put that in your calculators, give me an answer. You have got a log button. Should have if you've got the scientific calculator. $14.27. Yeah. If this interest is added every year, then that must be over, that'll be 15 years, because you've got to add, they don't add the interest to the end of the year, so therefore £15 years to reach more than £300. Alright? Are you happy with that? Yeah? Right. One more, and then you can have a go at some problems on your own. Okay? A drilling machine, so this is a typical engineering use. A drilling machine is to have 6 speeds ranging from 50 to 750 revs per minute. So what can we get from those two things that have been given us? I is 50. Come on, boys, concentration, please. What other information? What is 750? The first speed is 50. Second term will be IR. We don't know. Third speed will be IR squared. We don't know that. IR5 will be the first, second, third, fourth, fifth, sixth speed. So IR5 is 750. If the speeds form a geometric progression, determine their values, each correct to the nearest whole number. Alright, so what do we need to find to be able to do that? Yeah. So, how are we going to go about doing that? On the A to the power 5 is equal to 750. What can we do? We want R on its own. We know A. Now we've multiplied here, so how do we get A over that side? Okay. R to the 5. 150 over A. How do we cancel the fifth power? Fifth root. Yeah. What we got? 4 decimal places will do. That'll do. Yeah. Now we want to know what each of these ratios are. So, first term, I is 50. Yeah. How can I calculate the second term? 50 times 1.7188 equals 85.94. Sound 4, right. Yeah. 100 and yep, finish it off. Want the ratios to the nearest RPM. And the last one, what should it be? Yeah. So those ratios to the nearest RPM would be, first one is 50, that one will be 86, that would be 148, that would be 254, and that would be 436 and 750. RPM, each of them. Okay. So, on the next pages of your handouts, there are some geometric progression problems for you to work through, please.